Good morning, everyone. Today, inshallah, we will continue on the systems with the systems of equations. We already started some trials in the previous session. Those are some remarks. I found them really very good, so I wanted you to review them with me once more. Here it is written that A and A transpose are of the same type if and only if A is a square. What we mean about this, if you have a matrix for a general dimension m by n, if you make a transposition, you will have n by m. But if you have a square matrix, if once you do a transposition, it's going to be remaining square matrix from the same dimension. Okay, a square null matrix is simultaneously, a square null matrix. So it's a square matrix whose all elements is zero. It is at the same time an upper and lower triangular matrix, a diagonal matrix, a symmetric and anti-symmetric matrix at the same time. So it's a null matrix, and on the same setting, it is upper and lower and the diagonal matrix, symmetrics and anti-symmetric matrix. The product A times AT is always a symmetric matrix for any matrix A. So if you have a matrix and it's a transpose, if you multiply them, the result will be a symmetric matrix for any matrix of type A. The main diagonal of an anti-symmetric matrix is always null. So for any anti-symmetric matrix, in all times, the principal diagonal is going to be null. I found this remarks is really benefitable, so I wanted to share that with you. Also, in the previous session, we saw that sometimes if you multiply a matrix, a square matrix by itself, you will end up having unit matrix. Or once you multiply a matrix by itself, you will have the same matrix once more. Okay? Or it's going to equal to negative I. That's the problem that we solved yesterday. Okay? In the case of having A squared equal to A, it is said to be in the idempotent matrix. Idempotent matrices or matrices. This is the condition for this case is once you multiply the matrix by itself, the result will be the same matrix. So it's also a very nice or a very good information that you should have. Okay. This problem is 112 is one of the also very nice problems that I thought to share with you. He is giving you matrix A and matrix B, and he wants you to show that B is equal to A minus 1. Salma, any ideas? You have two matrices, A 3 by 3, B 3 by 3. I want you to show us that B is equal to A minus 1.
Transpose A
Mhm.
out.
Mm-hmm.
1.
أنا معك إنه to have an inverse A times B must equal to mean أو العكس. يبقى إذن all I have to do is to just multiply these two matrices in each other. If they came to unit matrix or identity matrix, so B is an inverse of A. So it's really very simple. So all I have to do is to write matrix A, which is 1, 0, 2, 2, negative 1, 3, 4, 1, and 8. And then multiply it by negative 11, 2, 2, negative 4, 0, and 1, 6, negative 1, and negative 1. Okay? Once we do this, let's see. Multiplying the first row by the first column. Let's do it. Together. 1 times negative 11, negative 11. 0 times negative 4, it's going to be 0. 2 times 6, 12. The difference between them, 1. If you try to multiply the first row by the second column, so 1 times 2, it's going to be positive 2. 0 times 0, 2 times negative 1, it's going to be negative 2. So the sum of them is going to be 0, and so on. So you will find that the multiplication will lead to a unit matrix. Either you multiply A times B or B times A. So now we are sure that A and B are inversions from each other. Also, I want you to know, if A is an inverse for B, or B is an inverse of A, it is vice versa. So both of them are inversions from each other. Okay, very good. He asks you to compute the inverse of C equal to 2, this matrix. So you will have to read. This matrix is simply matrix number 1, 2, 4, 0, -1 and 1, 2, 3, and 8. So what's the relation? In order to compute the inverse of the C matrix, 2 times all of this. And he told you that remark that C is equal to 2 times the A transpose. So if you look at this matrix and that matrix, they are the transposition of each other. So I can say I need to use or to take advantage from this end. Any ideas? Teddy, once more. What's the relation between this matrix and that matrix? This is the transpose of that matrix. طيب احنا عايزين نحسب مين؟ inverse of مين؟ of C. طيب ايه الريليشن اللي انا اقدر استفيد بيها من المعلومه دي؟ اهو ستيب باي ستيب، واحده واحده خالص. خلي بالك ان اسئله الامتحان بتجيلك في نفس المستوى ده. المستوى اللي موجود قدامك. تعالى نقرا. ده معناه ان سي بيساوي 2 times A transpose. مش هو ده اللي موجود؟ صح؟ طيب هو عايز يحسب مين؟ اللي هو بيساوي 2 في A transpose to the power of كام؟ وده احنا خدناه المره اللي فاتت. من البروبوزيشنز بتاعت الانفرجن، لو انا عندي باور او ترانسبوز لماتريكس لها انفرس، في ريليشنز بتربطهم ببعض. ايه الريليشنز اللي موجوده؟ رقم واحد، ال 2 هتبقى 2 to the power of -1. Then I have A transpose to the power of -1. طيب وهو A transpose بتاع -1 من البروبرتيز اللي احنا عرفناها دي تساوي 2 to the power of -1 في A minus 1 transpose. ما هو ده من البروبرتيز اللي احنا واخدينها يا جماعه. البروبوزيشنز اللي احنا بنعدي عليها في الانفرجن احنا خدناها المره اللي فاتت، انه A times A minus 1 is equal to I ان A minus 1 transpose بيساوي A transpose to the power of -1. ده اليوز بتاعها. طيب ركز كده بقى، انت من البدايه عارف ان دي A والانفرس بتاع ال A بيساوي كام؟ يعني اذا بكل بساطه انا I have C minus 1 in front of my eyes. It's equal to 1 over 2 times the transpose of the inverse of A. مين الانفرس of A؟ حد يمليني. -11 -4 6 بعدين 2 0 -1 بعدين 2 1 and -1. So simply C minus 1 is gonna equal to a half times -11 -4 and 6 then 2 0 -1 then 2 1 -1 multiplied by half. So C minus 1 finally C minus 1 will equal to these values: -11 over 2, then -2, then 3, then you will have 1 and 1, then you will have 0 and half, then the other two elements is -1 over 2, -1 over 2. That's the inverse of C. شوف السؤال متركب ازاي. الأول he wants you to test that A and B are inversions from each other. This is really very easy to do. How to do it? Just to multiply these two matrices together. You will end up having a great matrix. We already did that. Okay. He wants you to evaluate the inverse of matrix C, which is 2 times this matrix. And also he give you a hint. Maybe this hint is not going to be available in an exam or something. So if you do something like this, just give a good look to this matrix and one of these matrices. Once you take a good look for this matrix and that matrix, you will find this matrix is the transpose of A. So I started writing C is equal to 2A transpose according to his note. Okay? Second step, he wants you to evaluate C minus 1. So C minus 1 will equal to 2A transpose to the power of -1. We know that we can distribute the power. So the power will be 2 to the power of -1 times A transpose to the power of -1. 2 to the power of -1 is going to be half. So it's not a problem with me. Now for this property, I can replace the transposition and the inversion, or the inversion and the transposition. So I have this benefit with me. Now I know that A minus 1 is already given, this matrix. So all I had to do is just to replace them, replacing A minus 1 by the value of matrix B. Finally, I will transpose this matrix to be -4, -11, -4, and 6. After you have its transposition, multiply by half. So that's the inverse of matrices. If you want to check, it's really very simple. Okay? How to check if this is the correct answer? Simply multiply this value by the value of C, that matrix. Matrix C simply can be given by حد يمليه 2 times 1, it's gonna be 2, then it's gonna be a 4, 2 times 4 is gonna be 8, for the second row it's gonna be 0, -2 and 2, for the last row it's gonna be a 4, a 6, and 16. لو انا جيت اعمل multiplication للفيرست رو باي فيرست كولم هتلاقي الريزلت بتاعتك بتطلع باليونت ماتريكس. اوكي؟ يبقى انا كده اتشكيت. طيب هنا بيقول برضو خلي بالك، بيقول solve quickly بسرعه السيستم ده. بص على السيستم ده، انا عايز احل السيستم ده. It's a matrix A times XYZ equal to 1 double 0. It's very quick to evaluate. لسبب بسيط. هو انا لو عايز احل السيستم ده زياد، السيستم ده اقدر اكتبه ازاي؟ اقدر اكتب السيستم ده ماشي، هتكلم على دي هنا في الجزء ده بس. السيستم اللي انا شايفه ده هو عباره عن A matrix times a column matrix equal to another column matrix. الدايمنشنز بتاعهم بالسلمى A3 by 3 matrix X it's just only 3 times 1 and the matrix B is 3 times 1. So the multiplication is correct. صح؟ طيب how to solve it? Very simple. Multiply this equation by the inverse of A. صح؟ لما اضرب by the inverse of A ايه اللي يحصل؟ هيديني A minus 1 times A equal X equal A minus 1 times B. ما انت بتضرب في A minus 1 صح؟ لما اضرب A minus 1 times A it's gonna be unit matrix. Unit matrix multiplied by X is gonna equal to A minus 1 times مين؟ B. I times X is gonna be X. So it's simply A minus 1 times matrix B which is given. يبقى كل اللي انا هعمله اهو X بتساوي مين الانفرس بتاع ال A minus 1؟ هو مديهولي اللي هو B من البدايه اللي هو نيجاتيف 11 2 2 اهو، يبقى نيجاتيف 11 2 and 2 بعدين نيجاتيف 4 0 and 1 نيجاتيف 4 0 and 1 بعدين اللاست رو 6 نيجاتيف 1 and نيجاتيف 1 6 نيجاتيف 1 نيجاتيف 1. كل ده انا هضربه في الكولم ماتريكس which is 1 double 0. So simply X it's gonna be في ثانية multiply row by column. So it's gonna be negative 11. Once you multiply the second row by this column, so it's gonna be negative 4. The third column by this, the third row by this column, it's gonna be 6. Now you solve it.
وانا ليه ما ضربتش B في نيجاتيف الانفرس بتاع ال A؟
ما هو ده الانفرس بتاع ايه؟
مش هي X equals الانفرس بتاع ال A times B؟
بس مش البي دي، انا اللي هنا بس كتبت بي علشان انقل السيستم ده. ما هو ده عباره عن A times X، انا بس سميت دي بي. ثانيه واحده. I'm sorry. beat عشان ما تلخبطيش بس ده. خلي بالك ان السؤال ده اقدر اساله لك يعتبروا سؤالين مش سؤال واحد، سؤالين في بعض. اول حاجه لغايه هنا ده تفكيرك، وخلي بالك تافهه جدا سهل قوي. ليه؟ وسهل انك تجيبها. وبرده لو حد مش واخد باله مش مركز في المعلومه الاولانيه هيقعد يلف حوالين نفسه او هيبذل مجهود كبير جدا. ليه؟ لان هو بيقول لك لو سمحت هات لي سي بتساوي 2 في الفاليو دي، هات لي سي ماينس 1. لو انت ما خدتش بالك من الهنت دي، والهنت دي ممكن تعمل لك ايه؟ يعني ما عندكش خلفيه دي، عادي اروح امسك الماتريكس دي هعمل فيها ايه؟ هملتبلاي باي 2 صح كده؟ بعدين امشي في الانفرجن. اروح بقى احسب الفاليو اوف ذا ديترميننت وبعدين الكوفاكتورز وبعدين الجوينت بعدين صح؟ تعرف تعمل؟ لكن مجرد ان انا عندي الاي وعندي ماتريكس بي وعارف النولج ده كتبت الستبس دي ما بذلش اي مجهود. مجرد ان انا خدت الماتريكس دي عملت لها ترانسبوز وضربتها في 2 جبت الاسس. نقطه ثانيه، مجرد انك اثبتت دول او عندك المعلومه دي عشان تخلي حياتك اسهل، راح جاي على طول الستيب اللي بعديها راح مديلك السيستم ده A تايمز X ايكوال 1 دبل 0. انا عندي الانفرس فمجرد ما اعوض بي اجيب الماتريكس دي الاذر سايد هقدر احلها على طول. زياد معايا؟ دي واضحه؟ انا عايزك تفوق النهارده كده. انا بتكلم كلام كبير النهارده. طيب طبعا السؤال اللي بعديه ده سؤال مباشر قوي. هنا بيقول لك compute if possible the inverse of the following matrices. ليه قال if possible؟
عشان ممكن ما تبقاش
ايوه
بتاع ده
ايوه
مش قد بعض dimensions مش قد بعض.
ايه؟
ممكن يبقى dimensions مش قد بعض.
انا فاهم قصدك بس انا شفت بتعبر
ايوه
صح؟
ممكن يبقى
اللي انا فهمته انه ممكن الديترمينانت يبقى بزيرو، فلو الديترمينانت بقى بزيرو يبقى اسمها سنجولار ماتريكس. بالتالي لو سنجولار ماتريكس مش هينفع انك تلاقي انفرجن. بعدين المجموعه اللي هو مديها لك كلها سكوير ماتريسيز، يبقى انا هبدا اتشيك for the knowledge that I have at the time being. هبدا اتشيك to evaluate the value of a determinant. Once the value of a determinant doesn't equal to zero مفيش حاجه بتستوب، تقدر تجيب الانفرس. اتفضل يا فندم.
مش في السنجلر ماتريكس كنا بنعمل مثلا يعني في اول واحده 3 تايمز 4 و1 تايمز 2.
ما هو دي اسمها الفاليو اوف ا ديترمينانت اوف ذيس ماتريكس. لو هو طلع بزيرو يبقى it's called a singular matrix. Singular matrix are one of the matrices for which the determinant is equal to zero. طيب if it is non-singular so the determinant doesn't equal to zero so you will be able to get its inverse. كده تمام؟ اوكي. اي مشاكل؟ لغايه هنا في اي مشاكل؟ لو سمحت الشيت انا بعته لك ضروري تحاول تحل بايديك. حاول تحل مسائل بايديك. لان في اوت كم ان يجي لك مساله زي دي وانت تقعد تفكر فيها لوحدك. انت فاهمني؟ انا بحاول اساعدك بس شويه، بس عايزك في نفس الوقت ما اقدرش امنع البنفيتس انت تو ثينك اون يور اون. يجي لك مساله جديده وانت تفكر فيها ايه؟ بالداتا بتاعتك، بس لازم الاول تكون مذاكر. تمام؟ اوكي؟ اي مشاكل؟
عندي سؤال تاني.
اتفضل.
بس في نمبر
في دي 12 قول.
ايوه دلوقتي لما بعد ما جبت الاجابه لو عايز اتاكد ان هي صح فاقوم هعمل هضرب اللي هو بي.
انهي واحده؟ اللي هي دي؟ الجزء الاولاني ولا الجزء الثاني؟
هي التو
اللي هي سي بيساوي 2 ده؟
ايوه
طيب
هو مضرب
اللي هي ماتريكس سي
في بي
في الانفرس.
طلع الادين
في الانفرس.
ماشي
الانفرس اللي هو 1 اوفر 2 في ماتريكس بي.
ماشي ايوه
بس خلي بالك مش في ماتريكس بي، ماتريكس بي بعد ما تعملها ترانسبوز.
ايوه
بس
المفروض تطلع الادين مش كده يبقى انا صح.
يبقى انت كده مظبوط، ما ده اللي انا قلته. ادي سي ماينس 1 وادي سي زي ما انا عملت التشيك اللي هناك بالظبط. اوكي بيرفكت. طيب تعالوا بقى هنتكلم على خلاص ده. اوكي ده مهم قوي الفكره اللي انا مشيت بيها هنا، والفكره ازاي انا استخدمت البروبوزيشنز دي، لان ممكن يرتب مساله مفيش فيها اذر الترناتيف الا انك تمشي الستبس الاساسيه، انك تكتب البروبرتيز وتستفيد منها، فلازم تبقى مجمعها في دماغك. اوكي اللي انا هتكلم عليه دلوقتي موضوع مهم جدا جدا جدا، وهو الاليمنتري جروب اوبريشنز. in matrices in general there are او خليني امشيها بالستبس واحده بواحده كده. طبعا لو انا بحل system of equations ممكن system of equations ده يبقى 2 equations and 2 unknowns, 3 equations, 3 unknowns, 4 by 4, 5 by 5, 1000 by 1000 يعني 1000 equations in 1000 unknowns. طبعا لما بقى السيستم بتاعي بيبقى الدايمنشنز بتاعته كبيره انا مش بحلها او مش بتعامل معاه باي اكزاكت ميثود عن طريق الميثودز الاكزاكت زي ما احنا بنعمل. في ميثودز ثانيه ابروكسيميت الكمبيوترز بتخش فيها وخلافه. لكن احنا هنتكلم منلي على الاكزاكت ميثودز. من اشهر الاكزاكت ميثودز to solve a system of equations عندنا two methods. Cramer method ودي Cramer methods is very successful but it has limitation with the dimension of the matrix or the system of equations. The second method is Gauss-Jordan method اللي احنا هنشتغل عليها دلوقتي, which mainly depends on the row operations. In the previous lecture, we saw that any system of equations, like this one, we have E11, X1, which E11, E12, E13 are all coefficients, X1, X2, X3 are all variables, and the results B1, B2, B3 are the values of these equations. I believe in the previous, not the last one, but the one before, we already talk about the cases that you will have if you try to solve a system of two equations. We will have unique solution, infinite number of solutions, or no solutions. That's the general case of equations, or the solutions of equations. So this system of equations can be easily put into AX equal to B Omar. This system of equation, simply, I can collect all the coefficients to be the coefficient matrix, times X, which is the unknown column, which equal to B, exactly like the previous problem when we tried to solve it together. Okay, simply, this is the coefficient matrix, this is the unknown matrix, that's the independent results or the results of this system of equation. Okay, in order to solve any system of equations, as I told you, you have three options, or you have three outcomes, you are in between them. Infinitely many number of solutions, when the number of equations less than the number of unknowns. Okay, you have a system which is a unique solution, or only one solution, and this will happen when the number of equations equal the number of unknowns, and these equations are completely different than each other. Mainly, they are linearly independent to each other, okay? The final thing, or the third alternative, the system has no solution. We already saw this in the previous, one of the previous lectures. While you are solving a system of equations, you are in between these options. Okay, very good. So, that's the system, that's the coefficient, that's the unknown, that's the result matrix. This is called an augmented matrix. This matrix, it's called an augmented matrix. The augmented matrix is simply a combination between two matrices. How to get this augmented matrix? بص يا عمر, I will take the coefficient matrix, put it here. Then usually, I like to write this line as a dash line. Then I will put the results in this column. This is called the augmented matrix, which summarizes a system of equations. يبقى تاني once more. Any system of equations can be simply put into matrix forms. How to do it? First of all, it should be arranged. X1 under each other, X2 under each other, and so on. Take the coefficients, all of them, put them in one matrix. Then times a column matrix which contains the variables X1, X2, X3, and so on. And all of this will equal to the results. I can summarize this three matrices into one matrix, which is the augmented matrix. How we form the augmented matrix is very simple. Take the coefficient matrix and then increase one column, which is the results. Okay? There are plenty of ways to describe how we do the system of equation or to react or to act with it in order to solve this system. Okay? So I will start with each one of them and we will collect them together in the final. For this system of equations, first look, how many equations do you have? Two equations. In how many unknowns? Three unknowns. So let's try to put them in a matrix form. First of all, I should be sure that they are well arranged. Okay, x's beneath each other, y same way like, z, there is a z here which is 0 times z of course, and the results are -1 and 0. If I want to put them in a matrix form, I will collect all the coefficients. معايا جودي? So it's a 1, 2, 1, 1. And the -1, -2 and 0. Here is the coefficient matrix. Okay, in the column unknowns, which is x, y, and z, and the result will be -1 and 0. Remark. This matrix dimension is 2 by 3. This matrix is 3 by 1. So once you multiply them together, you will end up having 2 by 1. So you can equate each one of them, and once more, you will have your system. So if you multiply this matrix, the coefficient matrix by the x, y, z, you will have this 2 by 1 matrix, which equal to -1 and 0. So once more, you will get back to the system of equations that we have. Okay? Okay, any questions? Perfect. كده نخش بقى على جاوس. Carl Friedrich Gauss and William Jordan, they did wonderful by giving us the advantage of knowing the row switching between matrices, in general, row multiplication and row addition. There are 3 operations. They are really very famous. They are called the row operations in the system of matrices. What are the 3 row operations? Number 1, row switching. So I have the benefit of switching rows in a matrix, and I will get an equivalent matrix to this matrix. So we usually say, once you replace 2 rows, it's not gonna change the value of the system. Okay, multiplying any row by a constant number. It's also, you will have an equivalent matrix, and will be equivalent to the major matrix of the main matrix. Multiplying any row by a number, then adding the result to another row. It's gonna be exactly the same. The 3 operations Ziyad came from these equations. Look at this. x1 plus x2 plus x3 equal 4. x1 minus x2 plus 3x3 equal 5. 2x1 minus x2 equal to 16. Any 3 equations in 3 unknowns. If I give you the system in this manner, or change it, Omar, the second equation to be the first and the first to be the second, is it going to make a difference in this system of equations? No. Instead of giving you number 1, number 2, number 3, I've just changed them. Giving you this equation first, then that equation later. So there will be multiplying a complete row by a number. It's not going to make a change. Because simply, this equation is exactly the same if I multiply 2x1, 2x2, 2x3 equal 2 and 8. So that's the row multiplication. Okay, this equation is well balanced. So the left hand side is equal to the right hand side. If I added this equation on this equation, into this equation, the result will be a balanced equation. Is there going to be a difference or a problem with that? No. So these are the 3 main row operations, which we call it row operations. يبقى تاني once more زياد. How many operations do we have? 3 of them. Switching rows, multiplying a complete row by a number, multiplying a complete row by a number, then adding it on another row. These row operations, it came mainly from the meaning of the equations that you are dealing with. Okay? What are we going to do? I will talk about the bottom line. The bottom line is to try to form your augmented matrix. I will get an augmented matrix, which is a summarization of this system of equations. I will try to change the coefficient matrix to be a unit matrix through row operations, the row operations that we will do. The result, you will have your solution. Okay? This is the fastest way how to solve a system of equations. Okay, this order in system of equation or in dealing with a system of equation is a little bit different than the normal sequence in the main slides of Lisp. I just wanted you to know the row operations and to be comfortable with them. Then we will get back to the slides step by step. Okay? بص أنا دايما بين نقطتين. يا اما عايشك الاول الخطوات بديتيلز كبيره جدا فانت هتلوز الفكره، يا اما ناخد الاول ملخص ازاي اقدر احسب بالظبط احل سيستم، بعدين هنعدي على السلايدز واحده بواحده وهنتكلم تاني على الاليمنتري ماتريسيز اللي هي لينكد بالرو اوبريشنز، بس هتبقى تاخدها وانت بعد خلاص انت فهمت ايه اللي بيحصل. ماشي يا حاج؟ طيب. The main issue is to solve this system of equations. So, I want you to focus as much as possible. First of all, I need to form the augmented matrix. First of all, I will need to form the augmented matrix. The augmented matrix is really very simple. Here we go. This is the augmented matrix. I will open a matrix. I will collect the coefficient matrix in this part. So first of all, before you act, try to be sure that x1 are beneath each other, x2 same way like, x3, it's okay. Then start transforming these numbers. So it's gonna be 1, 3, and 2. The second column. No. This is A dash and okay. The second row, the second column, please. 3, 5, and 4. The third column is negative 2, 6, and 3. The first equation equal to 5. The second one is equal to 7. The last one is equal to 8. I will try using these 3 row operations, which are, once more, get that? Switching rows, multiplying one row by a number, multiplying row by a number, then adding it into another row. Okay, these are the 3 operations. طيب احنا عايزين نعمل ايه؟ We need to change the coefficient matrix to be 1 0 0 0 1 0 0 0 1. I will need to do this matrix or to change this matrix into an equivalent matrix on this form using the 3 row operations that I told you about.
switching ومالتيبليكيشن معلش.
Okay? طيب خلي بالك بقى انا هسويتش اهو هتشينج. First of all, first step is to be sure that this is called pivots. This is the element 1 1, 2 2, and 3 3. So what we are going to do is to be sure that the first element, which is 1 1, equal to 1. Then by using this pivot, I will make the elements beneath this one is equal to zeros. Then I will go to the second row for the pivot, making it first equal to 1. Then using this one to force the elements in the third and the first row to be zeros. Then I will go for the third row, step by step. Okay? I will start first by the first row. The first row is equal to 1, so the pivot is correct. This is the first pivot. Okay? I'll start a new matrix. أنا هتكلم على السيستم النهائي، أنا عايزك تعمله إزاي. That's a new matrix. ده new matrix. البيفوت الأولاني مظبوط which is positive 1. So I will write this row. Positive 1, 3, negative 2, and the result is equal to 5. Now, using this row, I will force the element beneath it to equal to 0. How to do it? Using the 3 operations that I told you about. I can multiply the first row by the same number but with opposite sign. So I will multiply the first row by negative 3. Then I will add it. Step by step, element by element. So let's do it together. Salma, negative 3 times 1 plus 3, so the result will be, once more, negative 3 times 3, negative 9. Plus 5, the result will be, negative 3 times negative 2, positive 6. Plus 6, so it's gonna be 12. Negative 3 times 5, it's negative 15. Plus a 7, so that the result will be negative 8.
ماشي بقى دكتور عشان ما فهمتش اي حاجه.
اوكي نعيد تاني. بص يا حسين، انا عايز باستخدام ال 3 رو اوبريشنز، ايه هم تاني قولهم لي؟ switching rows, multiplying row by a number. Okay, multiplying row by a number and adding it on another row. اوكي ايه اللي احنا عايزينه؟ عايزين to change this matrix to be on the form of a unit matrix. So I will do it column by column. The first element or the pivot of the first row is equal to 1. We are lucky because this number is equal to positive 1. So already I transfer the first row is exactly as it is. So it's going to be 1, 3, negative 2, and 5. 1, 3, negative 2, and 5. Now, by using this pivot, I need to force the number beneath it to be 0. How to do it? Search for a number. When you multiply it in 1, and then adding it on 3, the result will be 0. What's the number that once you multiply it by 1, and
Any
adding
number or
it on 3,
percent?
it's going to equal to 0.
يعني نمبر ولا المفروض يكون في ساعة؟
It's going to be a unique number, which is simply the same number but with opposite sign. So I will multiply the first row by negative 3 and adding on the second row. Let's do. لأنها الأوبوزيت بتاع 3 اللي once you add it together the result will be 0. ما هو أنا عايز أخلي التلاتة تبقى صفر عن طريق عملية جمع. إمتى التلاتة تبقى صفر عن طريق عملية جمع؟ لما أجمعها على نيجاتيف 3. طب إزاي هجيب نيجاتيف 3؟ هضرب نيجاتيف 3 في الفيرست رو. تعالى نعملها مع بعض كده واحدة واحدة. طيب لو أنا جيت أضرب الرو كله يا حسين وجيت أجمعه هضطر أعمل ده بره مش جودي. لكن اسهل لي اعمل رقم نمبر باي نمبر. لذلك ركز بقى قوي. we will multiply the first row by
يعني لازم column by column صح؟
by negative 3. هجاوبك بس دي لحظه. هضرب الفيرست رو بنيجاتيف 3. اهم حاجه الستبس. نيجاتيف 3 تايمز 1 بلس 3 عملت اللي انت عايزه صح؟ نيجاتيف 3 تايمز 3 نيجاتيف 9 بلس 5 نيجاتيف 4. نيجاتيف 3 تايمز نيجاتيف 2 6 بلس 6 so it's gonna be 12. نيجاتيف 3 تايمز 5 نيجاتيف 15 بلس 7